before our next break, it's all going to be on this board up here. So if you can't see, I would come up closer. I would dedicate a whole page, at least to these notes, put it landscape. What we're about to do is our foundation for CCNA 1. We talk about some of the things here in ITE, but we're just going to cover a lot of it now. So for the law of repetition for learning, we see it multiple times. When we get to CCNA, if you don't know this, have it memorized by the first test in CCNA, you're going to have a really hard time. Wing it. Write it multiple times if you need it. You're going to want to have this memorized by the time we get to CCNA. And only some of this is relevant to ITE. It's all relevant to CCNA. But it's going to help us, when we know the bigger picture, explain things. So mnemonics. So what we're going to learn now are different protocol models. We're going to learn the OSI, the Open Source Interconnect model, and the TCP/IP, or Transmission Control Protocol, Internet Protocol model. What these are two models for how data communicates. You send an email, what happens each step of the way? From all the way from the data, sending that email, all the way down. Huya? All right. There are, slow down, okay. Can't see the board? So we're going to learn, right, what's going on at each of these layers, etc. But you send an email, you send a file, right? What happens from all the way through each of these layers for it to get to its destination for sending and receiving? Give you all a second. So even though the TCP/IP model is what we use today, we're going to learn the more detailed and older OSI model. Then we'll learn how they correlate to each other. So there's 7 layers in the OSI model, and there's different mnemonics we can use to remember these layers. Please do not throw sausage pizza away. My favorite, please do not tell Shore Patrol anything. Or if you start from the top, you could do all people seem to need data processing. Whatever you want to do to remember. Which one do we like the best? The pizza? Please do not throw sausage pizza away. And with that one, we start at layer 1. So let's all say that together. Please do not throw sausage pizza away. One more time, everybody. Please do not throw sausage pizza away. Easy day? Every day is an easy day. Love it. All right, so layer 1, this is and if you want to write that mnemonic down so you can remember it, because when we get to CCNA, you've got to have this down, right? So that mnemonic, that's going to help you, right? Please do not throw sausage pizza away. Layer 1 is physical. So if I say something about layer 1, like a repeater or a hub that we'll learn about later. That's going to be at layer 1. Layer 2 is the data link layer. Some of us already might know what piece of hardware is at layer 2. A switch. We talked about that yesterday. Layer 3 is the network layer for OSI. Layer 4 is the transport layer. 5 is session. 6 is presentation. And 7 is application. What was that mnemonic we used to remember the OSI model?
Please do not throw sausage pizza away.
One more time.
Please do not throw sausage pizza away.
Layer 1 is physical. Please, physical. Layer 2 is data link. 3, not network. 4, throw, transport. 5, sausage, session. 6, pizza, presentation. And the top one, away, application. Please do not throw sausage pizza away. Physical, data link, network, transport, session, presentation, application, open source interconnect. Why do I feel like I'm saying that wrong? Okay. All right, the TCP/IP layer, that has 4 layers. At, in, or NIDA, or a tin, however you want to remember that one. So layer 1 and 2 of the OSI model, the physical and data link, that goes to 2 layers. There's 2 words here. This is network access. The network layer of the OSI model goes to the internet layer of the TCP/IP model. Layer 4 is a tricky one. Transport goes to transport. So just kidding. That's the easiest one to remember. It's always transport. For the very top, for TCP/IP, the session, presentation, and application layers of OSI go to the application layer of the TCP/IP model. We need more time? I did put this in your resources tab for both classes. So if you go to your class and you go to content and you go to resources, instructor added resources, it's right there as well. But write it down now, right? Muscle memory, writing it down. You want to have this memorized by the time we get to CCNA, and this is relevant for things we're going to be learning the next few days over 5 and 6. That's a great question. What's the best way to remember the OSI model, everybody? Please do not throw sausage pizza away. But the whole thing? I would probably just today, right? We're spending a lot of time writing it down. And then, right, see later on, blank piece of paper, how much of the chart you can get down with memory. And then whatever you can't do, look and fill it in, and then do it again until you've got it down. And then quiz each other, right? Because we'll talk a lot and be like, a layer 2 piece of hardware is, somebody already said earlier, a switch. So quiz each other on breaks. So let's move on to hardware. So layer 1, these are going to be dumb devices. They're not smart. They don't know where things are going. So one of the first pieces of hardware in the physical layer is a repeater. So a repeater, think about a copper Ethernet cable. Over time, the signal is going to degrade. So such as my voice, right, is coming out of my mouth at 100% volume. Right, I'm being really loud, but the further distance that it goes, it gets quieter and quieter. But if it hits a repeater, it's going to regenerate that signal out at 100 and then start to get softer again. Newton.
Is that the same thing as a hub?
Hub is different. We'll talk about that next.
So
Repeater. And then the next piece of hardware is going to be a hub. What a hub does is it just, whatever comes in on one port, it just repeats that signal or sends the same signal out every single device. Everybody gets it. You get a car, you get a car, you get a car. You get all the packet, you get the packet or the frame. We'll talk about bridges later on as well. Now, what device allows devices to connect to a LAN, to a network? A switch. So a switch is a layer 2 device. A switch is a layer 2 device. That allows us to communicate on our LAN, on our local network. But that won't allow us to get out of our network. What device will allow us to get out of our network? Router, right? And that's the boundary for our network. A router is a layer 3 device. All right, throughout this course, and more so in CCNA, we're going to break down all of these layers. But for now, we can just understand some basics about what's going on. In the physical layer, timing and synchronization. And later on in CCNA, we'll learn about the preamble and the start frame delimiter, the SFD. We'll learn about the individual bits. We'll break things down, how it goes over the medium. We've talked about different IEEE standards. Now, what device allows devices to connect to a network? A switch.
I had a question about, so what would you say about access point? Like, would that be in layer 3?
Access point would be layer 2. All right, a switch. We know that connects devices to our network, right? So we can communicate with other computers. Switches operate by looking at a certain address. And we'll learn about these addresses later on in chapter 6, but this address is called my MAC address. And another name for MAC address is our physical address. And we'll break these down, MAC or physical address, in chapter 6. A router, remember, that's our boundary for our network. That's how we get out of our LAN and forward data from one network to another. They operate and make those decisions based off of a different address, or our layer 3 address, which is our IP address, also known as, AKA, our logical address. Now, if you forget which one of these is which, well, our MAC address, another name for that is physical address, that's closer to the physical layer. Not in the physical layer, but it's closer there. In the transport layer, this is where our port numbers are added. We're going to learn about those when we talk about protocols. The port numbers are added in the transport layer. Now there's a question in the back.
So for the data OSI, is it important that we remember all of those different protocols?
We'll talk about that in a little bit. Not relevant for right now. For us, we're going to break down, we're going to talk about them in detail. So you're going to have to know about different email protocols in this course, etc. So for now, we're just going to know that they're in the application layer. But in between 5 and 6, we're going to learn about POP3. We're going to learn about IMAP. We're going to learn about different email protocols and what the differences are for each of those email protocols. So that's coming. So yes. All right, for the top 3, session, presentation, application, later on we're going to break down what's going on in each of those layers, more so in CCNA. So for now, the top 3, just think of that as encoded, application, data. All right, let's take a second back, right? These models, that's showing what's going on as we send something from one device to another device. Now, there's different things happening at each of these layers, so we refer to it as different things during this process when it's going through each of these layers. That's called a PDU, a protocol data unit. It starts with the data at the very top, or data for application, presentation, session. Whether that be email data, file data, web page data from a web server. And then it ends with, at the very bottom, bits. Those are the ones and the zeros that we learned about yesterday, right? Those binary bits. When it's going across an Ethernet cable with electricity, or maybe it's going through fiber with pulses of light, or electromagnetic waves with wireless. The very end, when it's going through that cable, we're just calling it bits. So it starts with data, ends with bits. But what's in between? Y'all are pretty new here, so you probably haven't made it to the beach because it's been cold. But if you did, what would you wear at the beach to protect yourself from the sun? Sunscreen. What is sunscreen measured in? SPF. So the transport layer, we call this segments. Plural. P is packets. And the data link is frames. So that's what's going on in each of those. And we'll come back to that in a second. But first, we'll talk about protocols. Another name for protocols is rules. Different rules that have to be followed. So for example, we have Internet Protocol version 4. That's Internet Rules, right? Version 4 for an IPv4 address, which we'll learn about in Chapter 6, which is 32 bits written in dotted decimal. An IPv6 address is 128 bits and written in hexadecimal. So they have different rules that they follow. So for Internet Protocol version 4, or IPv4 and IPv6, which TCP/IP layer do you think Internet Protocol version 4 and 6 go in? The Internet, right? So that's IPv4 and IPv6. Now this network access layer of the TCP/IP model goes to 2 layers of the OSI model, the data link layer and the physical layer. We're going to dive really deep into those later on. But for now, the network access layer, we'll just put a few protocols here, such as Ethernet. Do we remember the IEEE standard for Ethernet? 802.3. We have WLAN, or wireless LAN. We also have a protocol we're going to learn much later called ARP. It's where I know my IP address, but I don't know my MAC. Don't worry about that now. We'll get into that in a few weeks. Hoo-ya? Ah, awesome. If you said hoo-ya back, I know you were there. If you didn't say hoo-ya back, I don't know if you're there. When we get into commands, we're going to learn about a command called ping, where you can ping or send a hoo-ya, an ICMP echo request, to see if that computer is there. Hey, are you there, hoo-ya? And they say hoo-ya kind of back, right? So that ping that we'll learn about, that protocol is ICMP, and that's also in the internet layer. Now after we go through this, and then we do the next thing, we're going to break down some IP addresses. We'll learn about private non-routable addresses, which don't go over the public internet for IPv4. And those can be translated from private to public addresses, and that protocol is called NAT, or Network Address Translation. That's in the internet layer as well, and we're going to deep dive into that in the next few weeks as well. All right, I'm going to put a line here or a pipe. If you just want to prep for CCNA, we don't need to know this for ITE. We're going to learn, but there's some dynamic routing protocols. Routing can either be done statically or dynamic or automatically. So we're just going to write these down so we can start memorizing for CCNA. But some of these dynamic routing protocols include eGRIP or EIGRP, RIP, BGP, Border Gateway Protocol, used by internet service providers, OSPF, which is a CCNA 3 thing, but we learn about because that's what the fleet uses. What else do we got? Oh, that's probably enough. Question in the back? That's a great question. Let's wait till we get the application, and we'll talk about that then up there. But I see what you're thinking because it's an IP address, right? So it's a server. It's a DNS server. That's why it's up here. The transport layer has two protocols. Now what's happening when we send an email or any communication, it's first going to segment that data, that email, into multiple pieces so it can be managed easier. The first protocol is UDP, and it just sends it. YOLO. Just send. Just fire and forget. As fast as it can, it sends the data. It doesn't care if it gets there or not. If there's a device on the other side, it just sends it as quick as it can. That is UDP. The other one that's a little slower, but more reliable is TCP. What that'll do is it'll still segment all of the pieces of data, but it's going to number them with what are called sequence numbers, and it'll send them through. If any don't make it through, you'll know because they'll send an acknowledgement number. And we'll get into that later on. It's also going to verify someone's on the other side. But this is reliable. You're going to be able to get all of the data. If it doesn't make it through, it resends it. We'll talk more about these later. And at the very top, we've got a lot of protocols in the application layer. So anything that runs off of a server, offers a service, is going to be in the application layer. Now, some of these protocols, you may think they're in different layers. For example, there's a protocol that automatically allows you to get an IP address. I think, oh, automatically get an IP address? Oh, that should be here with IP, right? But this protocol, DHCP, that automatically allows you to get an IP address, that's a DHCP server. It's offering a service. That's going to be at the application layer. That's DHCP. To automatically get an IP address, we're going to break all of these down throughout this course. We have different web protocols. If you go to Facebook.com, you go to TikTok.com, YouTube.com, Google.com, those are all websites. Those are web servers or hypertext transfer protocol, HTTP. And there's a secure one called HTTPS, which we'll talk more about in a later chapter. There's different email protocols, such as Post Office Protocol 3. Does not leave a copy on the server. You have IMAP, you have SMTP, you have SNMP, etc. A bunch of email protocols and one that's not really. Let's see. Oh, you have different file transfer protocols. You want to store a file on a remote server. You have different ways you can do that with FTP. You have trivial or TFTP. When you go to a website, let's say facebook.com or mynavy.mil, we know that's a server, right?
Yes.
And every device has an IP address. So that server has an IP address. So really, when you're putting in that URL, you're going to an IP address. But humans would be really ridiculous and difficult to remember, oh, hey, did you go to 11.176.13.2? What? No, that doesn't make sense. No, go to mynavy.mil. Go to quick links. That's easier. But the computer still works, right, by going to that IP address of that server. So something needs to translate it from a URL to an IP address. That protocol is DNS, Domain Name Server or System. Later on, we'll also learn about RDP, Remote Desktop Protocol. We'll learn about LDAP, but we're probably a little bit overwhelmed already, so we'll stop adding some there. But later on, we'll add some more. Now, each of these protocols in the application layer, they have a port number assigned to them, which we'll learn about later how it's able to utilize that to keep track of conversations going on multiple devices, which device and which tab, etc., to keep track of the conversations. So the protocol have port numbers. DHCP has 2 port numbers. It has, first port number is 67 and 68. Now one of these is for server, the other is for client. How do you spell server?
S-E-V-E-R.
Server. How do you spell 7?
S-E-V-E-N.
Both of these start with S. So 67 or 68, which one do you think is for server? 67. They both start with S, right? 67 is for server. 68 is for client. HTTP, right? That's for our web pages or our web server. That's port 80. Or it could be 8080. HTTPS for secure. That's port number 443. POP3 is port number 110. IMAP 143. SMTP 25. Those are all email protocols that we're going to learn about later on throughout this course and CCNA. SNMP is port number 161. FTP for transferring files is 20 and 21. We'll learn about those differences later. TFTP is port 69. DNS, translate our URL to our IP, is 53. RDP is 3389 for remote desktop protocol. So what we're going to do is you need to know certain port numbers in this course and the next course. We're going to start today, right? Slowly memorizing all these port numbers. By the time we get to CCNA, we should have them down because you need to know them in ITE. When we get to CCNA, you're not going to have to just know the protocol and the port number and where it goes to, but you're also going to need to know if it's TCP or UDP as well. So that'll come in a few weeks. So you start working on note cards now, slowly memorizing it. Maybe if you make note cards, etc., put the TCP or UDP in parentheses. Don't worry so much about it now, but it's going to come in CCNA. Booyah? The branch, you with us? I know this is a lot right now, so we're just going to use the law of repetition to go over and over, and then we're slowly going to learn more and more and more about each of these layers and each of these protocols, etc. Good to go? All right, one more thing. So if we're sending an email, we're sending a web page, we're doing something like that, where do you think that's going to start at? The top or the bottom? Well, where's my email protocols? Where's my web protocols? They're at the top, right? That's the data, right? So if I'm transmitting a message, we start at the top. This is the encapsulation process. So as we're transmitting, we're going to start here, and we're going to work our way down. Now, let's say we buy something off of Amazon. What do you want to buy off of Amazon? Car parts. You buy a car part. Like, you buy a car part. We'll just do, there you go. There's a car part right there. Do they just take that part, put it over here, and it magically gets to you? No. What do they need to do?
They just pack it.
They put it in a box.
Make a tracking number.
The tracking number, what kind of information's on that, the label?
Address,
The name, the address.
Where it's going to, where it's coming from, right? And some other information. And then that's going to go on a truck, right?
Yes.
Running out of room. Driver. And that goes across a road, right? Now, once that box gets there, do you care about that truck driver anymore?
No.
No. You care about that shipping label
No.
or the box? All you're going to be left with is your package or your data. So when we're transmitting, that's the encapsulation process. We start with our email or our web data. Then we add our port numbers. It's getting larger. It's adding more overhead. Anything other than our package, our data, right? That's overhead. That's excess. So it's encapsulating. It's getting larger. We get to the internet layer. We're going to add more. We're going to add our IP address, etc. The data link in the frame. We're going to add our MAC address. And then it goes across the wire, just as the ones and the zeros. So encapsulating, we're sending, we're receiving. It's getting larger. I'm sorry, we're sending, we're transmitting. Starts at the top, getting larger and going through. Now, if we're receiving, right, we're decoding the message. That's going to be at the bottom. Watkins, who is your favorite character from Degrassi that was in a wheelchair that became a rapper?
Drake.
Drake. Where did Drake start from?
From the bottom.
The bottom. So we have de-encapsulation.
Damn, Degrassi.
Just like Drake starts at the bottom. Drake, de-encapsulation D, that starts at the bottom and goes up. That's the de-encapsulation process, which we'll dive into more later.